Oh, hi. Right, today we're going to look at doing the vectors on the higher paper. Because a lot of people do tend to struggle with this, so I figured let's go through some of the basics. Right, the first thing we need to know is how to write a vector. And that happens when we have two coordinates, but it's not done in the normal coordinate way, we have to do it a different way. So it's nice big brackets, an x value and a y value. And the way this means is depending on the horizontal or the vertical. So we've got the horizontal and the vertical. The best way to remember this is if this number is positive, we move to the right, and if the number is negative, then we move to the left. And it's a similar situation for the y. If the number is positive, we move up, and if it's negative, we move down. And that's usually how we write a vector. So we've got a couple of questions. What are the vectors? Well, we need to have a look at the starting point and the end point. This vector on the left, it's called vector A or vector AB. So there's a few ways we can write it. We could have A, AB, with an arrow on the top to say it's going from A to B, or we could use the method we've just gone through, and we're starting at A, we go across 1 square, so that would make that a 1 on the top, and up 3. So again, that's positive, and there's our vector for that one. If we look at the one on this side, we are going from C to D, so we're going from right to left. So a start point down at C. We're going across left 2, so that's going to be -2. And we're going up 1, so again that's positive. Again, that could be called vector B because it's labelled, or vector CD with an arrow, because it's going from C to D. We've got another question. It says draw the vector -4, 2. Now there's no start point, it's not given to us, so we can just pick a start point. But from on the first slide where it said going left would be a negative top number, we need to know we're going to have some space on the left. So I'm going to pick my spot just there, and it says 4 -4, which means we go left. 1, 2, 3, 4 right to the end of the board, and 2 up to there. So obviously you'd have a ruler, and I'm not going to waste time trying to find mine on the board. And label your vector because it's got to go the way it's telling you. So we're going from there to there. Usually in the question it might give you something to work letters to put in, so like A, B for example, and then you just draw it on some graph paper. Then we've got these sort of questions. These are much more difficult because we're given the vectors and we need to know what A plus B is, what 2A minus B is. This is where people start to get a bit more confused. So what we do is we find the vectors first. So if we look at A, it's very similar to the one earlier. Across 1, up 2, and you can tell this because of the direction it's given. So across 1, up 2. And this one on the right hand side, vector B, we're starting there, we're going across 3 and up 1. So that comes from the earlier slides. So A plus B, this one's not too bad because we're just doing 1, 2 plus, and then in this bracket -3, 1. Now we're going to assume that if you're doing vectors, we know how to do pluses and minuses together. So 1 plus -3, -2, 2 plus 1, 3. So your answer for 1 is -2, 3, and you could draw that vector as well. Pick a point, -2 to the left, so drawing left, 3 up, and you could draw the resultant vector as it would be called. Just rub that out, so we can do question 2. So question 2, 2A minus B, this is where we get a bit more confusing because the pluses and minuses get a bit more involved. So 2 lots of A, now I'm going to just jump in and do that straight away because I want 2 lots of that, so that's going to become 2 over 4, take away just B, so -3 and 1, and that vector is going to be the tricky bit that a lot of people get caught out with, 2 minus -3. and 2 minuses make a positive, so that would be 5, actually over 5, over 3. We all make mistakes, we're only human. So 4 take away 1, that's 3. A classic teacher would say, I'm just testing you, which I'll say, I'm testing you. Alright, so that's that one. And then I wanted to look at some exam questions, so I've picked 2, broken it down into its 2 parts. So it's all well and good knowing these to draw on a square, but then we're going to need to do this as well. So it says express OM in terms A and B. Well, we know that means we're going from O to M, because the arrow is pointing that way. So I need to know this here. Best way to think about it is we can only take the roads given to us, which are the ones with the arrows on, the vectors. So I know to go from O to P. Are you okay, sir? To go from O to P, I know that I'm going to have to go along the road A and along the road B. So I can go A plus B. So that would give me, so I would say that O to P is the vector A plus B. But we don't want O to P, we want O to M. Well, it tells us that M is the midpoint, so it means it's in the middle. And if it's in the middle, it's half of something, so we can half all of this. So we know that O to M is going to be half of A plus B. Quite a tricky thing to do, because you have to get your head around the fact that you're going from there to there and half in it. Very tricky. The second part of that question would then say express T to M. So a lot of people make the misconception of going from T straight to M like this, and they get confused. You can't do that. There's no road there. Alright, there's no road, so we can't go that way. But we need to get from here to here using the roads available. Well, usually in a question like this, they give you the first part to help you with the second part. So we know that this one from here to here is a half A plus B in that little section. So I know that that road is the vector half A plus B. So I can go against the traffic. The way I try and tell people is you're going against the traffic. So A would be this way, minus A would be going the other way because we're going against traffic. So I know to get from T to M, I need to go minus A, and then I need to go plus because I'm going with traffic again, so plus 1/2 A plus B. It might say simplify, in this case it does, so that's just a case of let's think outside the box a little bit. I don't want to spend too much time in this section because I just want us to realise about the vectors, but that's going to be a half of A, take away A, so we're going to have minus a half A, and then we've got plus a half B, and that would be the vector T to M. If there is any problems with this sort of section and you're thinking how's he just got that, well, the best thing to do is just think or comment on the expanding brackets, and if you need me to do another video on the expanding brackets, then please comment and I'll sort one of them out for you. Second question we're going to look at is just we've got some vectors around parallelogram, so we know the facts of a parallelogram hopefully. M to B, we're going from here to here. Well, we've got to think, well, how can we get from M to B with what we know? Well, luckily, when vectors are parallel, they're the same. So if we know that's A, this vector as well going up is going to be A. This is C, which means that this vector going the same way is going to be C as well. So luckily we're going from M to B. Well, if all of that's A, M usually represents the midpoint, so we are doing 1/2 lot of A with traffic, so it's positive. M to N, again it's one of those tricky ones where we're trying to get from M to N, halfway to halfway, but we already know this is 1/2 of A. So if we're going with traffic, we go up from M to B, half of A there, and we need to go, we know that going with traffic, that would be C, but we're going against the traffic. minus C. But again, we're not going the whole way, we're going half the way. So we're looking, this is where it gets a bit complicated, minus half of C. So that's because we're going against traffic, that's the minus. We're going halfway on C, so that's where the minus half C comes from. Plug that all in, and we get a half A minus a half C. So you're just combining the two, because it's like saying I need to get on this motorway and this motorway to get there, with traffic or against traffic. But obviously that'd be very unsafe. And then the last part of that question, prove that C to A, is parallel to M to N. So again, we know what M to N is, we've just worked that out. It was half A minus a half C. So let's work out C to A. So we know that's M to N. So C to A, we're going from this corner here to this corner here. Well, the best way to look at that is, again, we're going to start in here. We're going against traffic straight away. So we're going to, we say C to A against traffic minus C, because we're using the whole length of C. And then we're going with traffic along here. Plus A. Now I can see some similarities there. We've got a minus C and a plus A. We've got a minus C and a plus A. So I'm just going to rearrange that. Call it baby A. A take away C. And then you've got to think, well, we're getting closer now. Well, I've got an A take away C, A take away C. So what we have to do is we have to factorise this one and take the half out. So that can become a half, in brackets, A minus C. And just by doing that, you've proved that they're parallel, because this vector and this vector are the same. They've got the same magnitude, they're just a different size. So for example, they might look something like that and that. So they're parallel, but just different sizes, because that was half the size. So I'm hoping that made vectors a little bit more helpful. I might have gone a bit too fast. This is my first video. But any comments would be most helpful. Anything you need, just put a comment on and I can try to do another video. But I hope it helps. I've been Mr. Holt, and you've been great.